Okay, so this is day 2 of section 6.1. Yesterday we looked at law of sines, but we only looked at the scenarios where we had two angles and a side, and either the side was in between the two angles or it was not. When we have those situations, there's nothing to worry about. But if you have two sides and an angle, you need to be careful. There's basically three different things that could happen. So here's the first thing that could happen. Here's our scenario. We've got a side, another side, and then an angle. If the side across from the given angle is larger than the other side, so 34 is the side across from the angle, and 34 is larger than 21, then you got nothing to worry about, okay? So you would set the problem up just like we did yesterday. So we can do sine of 76 degrees over the side across from it, 34. And that will equal sine of this angle. Let's call these angles something. So we'll call this angle B and that angle C. So we can do sine of angle B divided by the side across from it, which is 21, and we can solve this now. So cross multiply. 21 times sine of 76 degrees would equal 34 times sine of angle B. We would divide by 34, and that would give us sine of angle B. Now you can type all of this in your calculator, and when you do that, you're going to get 0.5993 equals sine of B. And again, if we're solving for an angle, we need to do the inverse trig function. So in this case, the inverse sine of 0.5993. And when you type that in your calculator, you should get 36.8198 degrees. So that's our angle B. 36.8198 degrees. Okay, so then we could find angle C. All of the angles inside of a triangle add up to 180 degrees. So we can do 180 minus 76 minus 36.8198. And we will get 67.1802 degrees for angle C. So we've got angle B, angle C, and now we should find the side across from angle C, side C. So we could do sine of 76 over 34 again, and then set that equal to sine of angle C, which again is up here, 67.1802 degrees, divided by the side across from it, side C. And when you cross multiply this and work through it, you're going to get 32.2982. So that's side C, angle C, and angle B. Okay, so again, even though this was side-side angle, oh, do you remember in geometry when you were proving triangle congruence, side-side angle was not a method to prove triangle congruence? And you might have been able to remember that because it spells a bad word backwards. So when you see this configuration, you need to be careful. So the first thing that could happen is that the side across from the given angle is larger than the adjacent side. And if that's the case, you just proceed like normal. There's really nothing to worry about. But if the side opposite the angle is shorter than the adjacent side, you've got to be careful. So here's that kind of scenario. Draw a triangle, and in all honesty, it does not need to be accurate, okay? So A, B, C, let's say. Side A is 15. Angle A is 85 degrees. Side B is 25. So already my picture is not great. 15 in my picture looks longer than this side 25, but really don't worry about it. Don't get stressed out about drawing your picture perfectly. It's just there as a guideline to remember what's across from what. Okay, so in this particular example, the side across from my given angle is shorter than the adjacent side. So watch what is possible, what can possibly happen. Set up your law of sines. So sine 85 degrees divided by the side across from it, 15, equals, and then I can do sine of angle B divided by the side across from it. So sine of B divided by 25. Okay, so we're going to cross multiply. 25 times sine of 85 equals 15 times sine B. We need to divide by 15 and type that in your calculator. Okay, when you type in this in your calculator, you get 1.66032. And in order to solve for angle B, we would have to do the inverse sine of 1.66032. Now type that in your calculator. For real, pause this, type it in your calculator. When you do, you're going to get some sort of error message. It'll either say non-real calculation, it might actually say error. But the idea is, you know, when you're looking on your unit circle, the value of sine is never bigger than 1. And here we have a value that's bigger than 1. So it just, there is no angle where sine is bigger than 1. So we get an error message. So that's one thing that might happen. If the side across from the angle is shorter than the adjacent side, you might get an error. And what that error means is this. Okay, the side across from our angle A was just too short to even close up that side, so it's not even a triangle. So you could say no solution, you could say that it's not a triangle. Okay, either of those would be your answer to this question. And you don't realize it, I mean, you set up law of sines, you don't realize it until you get this error. That means it's not a solution, not a triangle. Here's another thing that could happen. So again, in this problem, the side across from my angle, 12, is shorter than the adjacent side, 31. So this so far looks the same as this problem. So start setting up law of sines and we'll see what happens. So we can do sine of 20 degrees divided by the side across from it, which is 12, equals sine of angle B divided by the side across from it, which is 31. Okay, do your cross multiplying. Divide by 12. Okay, and then When you type this in your calculator, you you get 0.88352. All right, take the inverse sine of that. And I know we're not going to have a problem because this value is not bigger than 1. So when you type this in your calculator, you'll actually get an angle. And you end up getting 62.07. Okay, so far it seems like there's no issue, right? But again, I said before, when you learned about triangle congruence in geometry, this was not a configuration that guarantees congruent triangles. So what that means is, if this angle is fixed, 20 degrees, is not going to change. This side length, 31, is not going to change. This side of 12 is not going to change. But here's the thing, angle C could change. So this angle could get smaller or larger. So this side of 12 right here could go inward like that. Okay, so it still is a length of 12. This is 12, this is a length of 12. But now what I have is a whole different triangle. So if I maybe, let me try to highlight here. So this side of 31 stays the same. This side of 12 stays the same. This angle 20 stays the same. But now what happened is angle C got smaller. And this angle, which would be a different option for angle B, this angle is now bigger than what angle B used to be. So we have two different triangles with the same given information. So here's what you want to do is draw the second version of the triangle. So same 20-degree angle, same side 31, same side 12. It's just angle C is now different and angle B is now different. And we're going to put primes to indicate this is the second option. Okay, now we need to figure out what this angle B could possibly be. The original angle that we found right here was 62.07 degrees. This little triangle is an isosceles triangle. We've got two sides that are the same length. When you have isosceles triangles, their base angles will be congruent. So this little angle down here is also 62.07. But what I want is this angle B prime, which is the same as this angle right here. And do you notice how these two form a linear pair? So they add up to 180 degrees. So if I want to find the second option for angle B, B prime, I'm going to do 180 minus the angle that I found, 62.07. And that will give me my other possible angle B. So when we do 180 minus 62.07, we get 117.93. So one of my triangle might have angle B of 62.07. My other triangle can have angle B at 117.93. So this is what I would recommend that you do when you start these problems. Let me get an eraser here and clean this back up. Okay. So here's the first possible triangle. Here's the second possible triangle. You set up law of sines like normal and you get an angle. But again, remember, the side across from the given angle was shorter than the adjacent side. And we did not get an error message like we did in this example previously. We did not get an error. So that tips us off that, oh, there's a second version of the triangle. So right away when you get this first angle, subtract it from 180 to find what the other possible angle B could be. Okay? Then from there, after you've got your two triangles drawn and your first set of angles found, then you can just go and solve the rest of both triangles. Okay, so I'm going to continue. Maybe I'll try to put a little division here. All right, so for the first triangle, I could now find angle C because I know all three angles add up to 180. So 180 minus 20 minus 62.07 is going to give me, for angle C up there, it'll give me 97.93. So now if I want to find side C, I would set up law of sines again. So I could do sine of 20 degrees divided by 12 and set that equal to sine of angle C, which we just found was 97.93 degrees, divided by side C. And when you work through that, cross multiplying and stuff, you're going to get 34.75. So this is side C, this is angle B, this is angle C in our first triangle. Okay. And it just helps if you write everything nicely or label your picture or something so I can see your solutions. Then over here, I can find this angle C, C prime. Again, all the angles add up to 180. So I can do 180 minus 20 minus 117.93. And that will be up there, 42.07. So angle C is 42.07 degrees. And now we can find the side across from that, side C prime. So I'm going to set up my law of sines. I can do sine of 20 over 12. And I can say that that is equal to sine of C prime, which again was 42.07, divided by the side across from it, which is C prime. And when you cross multiply and solve for C prime, you get 23.51. And this was angle C prime. So I've got 3 things for the first triangle and 3 things for the second triangle, total of 6 things. This is called the ambiguous case. If you're curious, if you want to see other videos, go ahead and just YouTube it. Law of sines, ambiguous case, and you'll see more examples like this. So the big question that people ask is, how do I know when it's going to be this kind of problem? So here's how you know. If your scenario is angle, angle, side, or angle, side, angle, if you're given 2 angles and a side, then everything is good, nothing to worry about. But if you have given information that's 2 sides and an angle, you got to be careful. First thing to check for is what's happening with the side opposite the angle. If the side opposite the angle is longer, so going back to here, if the side opposite the given angle is longer than the adjacent side, you're fine. Okay, so you're fine if that happens. But if the side opposite the angle is shorter, then two things could happen. Either you could have no triangle, and you'll know that because you get an error, or if you do not get an error, that means two triangles. So in order for this to even happen, you have to have, let me highlight it, you have to have side-side angle first. The side across from the angle has to be shorter than the adjacent side. And we actually get an angle. We do not get an error. That's how you know there's going to be two triangles. So you draw your second triangle, and it does not have to be an accurate picture. Just make sure you have the same given information. So same angle, same given sides, okay? And then you take your first angle that you found, subtract it from 180 to get the second possible angle. So this was angle B, this is B prime. Once you have that, you just go and solve for all the rest of the missing pieces on both triangles. And this is not going to happen that often, but you need to be able to identify when it happens. So again, it's the side opposite the angle is shorter. Well, first of all, it's side-side angle. Then the side opposite the angle is shorter, and you do not get an error. That means it's two triangles. Okay, so a lot of things have to happen in order for it to be two triangles. Another thing that might be helpful, this is in your book. This is on page 406. Take it or leave it. If you like this kind of thing, go for it, but you don't have to pay attention to this necessarily. Okay, so then your homework for today, Wednesday, is to finish the 6.1 worksheet that you started on yesterday. So now you're going to be able to do these 4 problems, and you'll be done with the worksheet. All right, I might see you tomorrow, Thursday. If we have school, remember that this worksheet will be due, and the 5.4 to 5.5 review worksheet will be due, and we will have that quiz on 5.4 to 5.5. Okay? All right, see you tomorrow.